Hello and welcome to yet another video of Cornerstones of Math, and today we are back to sequence problems again. Today we are going to solve one of the most basic types of recurrence relations. So we are given two problems, and for the first one, it is given that a1 equals 5 and an plus 1 equals an plus 6n for all natural numbers n. And for the second problem, we have a1 equals 1 and an plus 1 equals an plus 1 over square root of n plus square root of n plus 1 for all natural numbers n. Notice that they are the same type of recurrence relations, both in the form of an plus 1 equals an plus some expression fn. And there exists a general method of solving this type of recurrence relations. For the first one, notice that the difference an plus 1 minus an is given as 6n. Now let us substitute n equals 1, 2, 3, and so on, all the way up to n minus 1 to see what happens. When n equals 1, we have a2 minus a1 equals 6 times 1, and when n equals 2, we have a3 minus a2 equals 6 times 2, and when n equals 3, we have a4 minus a3 equals 6 times 3, and so on. And finally, for n equals n minus 1, we have an minus 1 equals 6 times n minus 1. Now notice that if we add them up, we have a2 cancelled out, and a3 cancelled out, and a4 cancelled out, and so on. And for the last part, we have an minus 1 cancelled out. So on the left hand side, we are left with an minus a1, and on the right hand side, we have 6 times 1 plus 2 plus 3 plus so on, till plus n minus 1. Here, it is given that a1 equals 5, and using the formula for the sum of natural numbers, we have an equals 5 plus 6 times n minus 1 over 2, which is 5 plus 3 n squared minus n. So we have an equals 3n squared minus 3n plus 5. And this is the answer. For the second problem, we do the same. But first, let us simplify the expression for the difference an plus 1 minus an a little bit, which is 1 over square root of n plus square root of n plus 1. We rationalize the denominator by multiplying square root of n plus 1 minus square root of n on both numerator and denominator. Then, on the numerator, we have square root of n plus 1 minus square root of n, and on the denominator, we simply have n plus 1 minus n. So we simply have square root of n plus 1 minus square root of n. So we have this, and substituting n with 1 to 3 n minus 1, we have a2 minus a1 equals square root of 2 minus square root of 1 for n equals 1, and a3 minus a2 equals square root of 3 minus square root of 2 for n equals 2. And we have this, and so on. And for the last one, we have an minus 1 equals square root of n minus square root of n minus 1. If we add them up, on the left hand side, a2 cancel out, a3 cancel out, a4 cancel out, and an minus 1 cancel out. So we have an minus a1. And on the right hand side, square root of 2 cancel out, square root of 3 cancel out, square root of 4 cancel out, and square root of n minus 1 cancel out. So we have square root of n minus square root of 1. And it is given that a1 equals 1. So we have an equals 1 plus square root of n minus square root of 1. So we have an equals square root of n. And this is the answer for the second problem. In general, for recurrence relations given as an plus 1 equals an plus fn, we can find the general expression for the nth term by a1, the first term, plus we add up the difference between adjacent terms, ak plus 1 minus ak, from k equals 1 to n minus 1. Remember that this part must be n minus 1. So we have a1 plus sigma from k equals 1 to n minus 1, fk. And that was all for today's video. Thank you all for watching, and I will see you in another video.